Given that the sum from k equals 0 to infinity of x to the k over k factorial is convergent for all real x, show that e to the x equals the sum from k equals 0 to infinity of x to the k over k factorial using the following steps. Part A. Show that if y of x equals the sum from k equals 0 to infinity of x to the k over k factorial, then dy by dx equals y. So we're going to write the power series out, and we're going to differentiate it and show that it actually equals the same thing. Because remember, this is a power series to infinity. So just having one less term once we differentiate and a constant disappears doesn't make any difference. Part B, so the second step of this show that, is to solve the differential equation dy by dx equals y to obtain a general solution. So that's just separate variables and integrate. Hence, prove that e to the x equals the sum from k equals 0 to infinity of x to the k over k factorial. So we're going to then find a particular solution and show that it actually gives the series. Okay, so for part A, we're told that y of x, so y equals the sum from k equals 0 to infinity of x to the k over k factorial. X to the k over k factorial. So that is going to be x to the 0 over 0 factorial, x to the 0 over 0 factorial, plus x to the 1 over 1 factorial, plus x to the 2 over 2 factorial, plus x cubed over 3 factorial, and so on, all the way up to x to the n over n factorial. Okay, if we tidy this up a little bit, we're going to have y equals x to the 0 is 1, 0 factorial is 1, so the first term is 1, plus x to the 1 is x, 1 factorial is 1, x over 1 is x, and then everything else just stays the same. So plus x squared over 2 factorial plus x cubed over 3 factorial plus dot dot dot. Okay, so we have been asked to find dy by dx, so I'm going to differentiate this power series. So dy by dx equals, well, if we differentiate 1, that's going to be nothing, plus the derivative of x with respect to x is 1, plus, and then you've got the 2 coming to the front, so you've got 2x over 2 factorial, plus 3x squared over 3 factorial. Might just include one more term, so it would have been x to the 4 over 4 factorial, so that would be 4x cubed over 4 factorial, and so on. If we just look at these, we've seen these simplifications quite a lot. Consider 2 over 2 factorial. Well, 2 factorial is just 2 times 1, which is 2. 2 over 2 is just 1, so this term will just be x. If you consider 3 over 3 factorial, well, 3 factorial is 3 times 2 factorial. So if you have a 3 on the top, a 3 on the bottom, they cancel out, and it'll just be x squared over 2 factorial. In exactly the same way, 4 over 4 factorial is 4 over 4 times 3 factorial, which will, the whole term will end up being x cubed over 3 factorial. So that means that dy by dx equals, well, the zeros disappear, so you get 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus, and you're going to keep going, x to the 4 over 4 factorial plus dot dot dot, and it is going to keep going all the way up to x to the n over n factorial, because there's an infinite number of terms. The fact that we lost this 0 means it makes no difference. This is a series from k equals 0 to infinity. It is exactly the same. This, you can see, is exactly the same as what we were given before. Dy by dx equals the sum from k equals 0 to infinity of x to the k over k factorial equals y. Okay, so we've done the first bit of the proof. Okay, part B, solve the differential equation dy by dx equals y to get the general solution. Okay, part B, dy by dx equals y. So we want the y with the dy by dx. So So we're going to divide both sides by y. That would say 1 over y dy by dx equals 1. Remember, if you divide y by y, you leave a 1. Right, so now we can integrate both sides with respect to x. So the integral of 1 over y dy by dx equals the integral of 1 dx. Okay, so simplification dx, 1, 1. So we have the integral of 1 over y dy equals the integral of 1 dx. Integral of 1 over y dy equals the integral of 1 dx. Very friendly integrals. You're going to have ln of the absolute value of y equals x plus c. Remember, we only need one constant, because if we had a constant on each side, we could just combine them anyway into one constant. I'm leaving it on the right-hand side because the general solution is going to be y equals something, not x equals something. So ln of the absolute value of y equals x plus c. We want to make y the subject, so we raise e to the power of both sides. E to the power ln y is just y. So y equals e to the power x plus c. If we look at that, we can call that e to the x times e to the c. Y equals e to the x times e to the c. And then we're just going to call e to the c a. So let big A equal e to the c. So then the general solution is going to be y equals a e to the x. General solution is y equals a e to the x. Okay, on to part C. Right, so we have just found the general solution to dy by dx equals y, and we've also shown in part A that if y of x equals the sum from k equals 0 to infinity of x to the k over k factorial, then dy by dx equals y. So we know that this is a solution to this. We're looking to prove that these are e to the x and x to the k over k factorial are equal, right? So since y equals the sum from k equals 0 to infinity of x to the k over k factorial. So since this is a solution, to dy by dx equals y, which we just solved. So since we've shown in part A that if y equals x to the k over k factorial, the series from k equals 0 to infinity, then dy by dx equals y. We've just also shown that if dy by dx equals y, then y equals a e to the x. So if we equate them, therefore, the sum from k equals 0 to infinity of x to the k over k factorial must equal a e to the x for some constant a. So that means that 1 plus x squared over 2 factorial plus dot 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 must be equal to a e to the x, right? So we've got to find the value of a that makes this true. If we look at initial values, when x equals 0, if you look at the left-hand side, that would be 1. LHS equals 1. RHS is going to be a times 1 because you've got e to the 0 is 1, a times 1 is a. So basically 1 equals a, which means that a equals 1, and so finally e to the x equals the sum from k equals 0 to infinity of x to the k over k factorial for all real x.